about talking about database architectures, and I'm one of the product managers at MySQL, and one of my products is MySQL Replication, high availability, middleware products. So that's where I'm a product manager of. At Oracle, and the database architectures that I'm talking about is mainly high availability and disaster recovery solutions. So everything that I'll talk about, and it's not very clear, I'm not trying to sell you anything, I'm just trying to show you some products that we have that are open source, right? So whatever I'll talk about is freely available, everybody can use it, try it out, break it, whatever, right? But before we get to that, I want to give a little recap on business requirements, right? Because it's important when I talk about different MySQL database architectures is that we kind of say like, how do you choose which architecture, right? What is good for whom or what business, right? And the two concepts I suppose most of us are familiar with this is a recovery time objective and recovery point objective. So RTO, recovery time objective is how long does it take to recover from a certain failure? And a recovery point objective is how much data are we or can we lose when a failure occurs, right? So that's important. We have this lined out here. So we have time, there's a failure. So the RTO is how long can you afford to be down? And then the RPO is how much of that data will you lose when a certain failure happens? So this is important question to ask your business, your application, it's important to know this before you can go and design and choose a certain database architecture for anything, really. Now, the type of failure is, there's a couple of different types of failure that we have, and to kind of summarize, we have three, right? We have high availability, and that is within a single kind of region or data center, or however you want to see it, a single server failing. So let's say we want high availability, so we want no data loss, RPO 0, when a single server fails or when a network partition happens, then yeah, that's high availability. Disaster recovery is when a region fails. How much time do you have? So what's the RTO for activating another data center, or is it seconds, minutes, hours? And then we have a third kind of failure is human error, like little Bobby tables, like drop database by accident or an application bug. How fast can we recover from that? There's a couple more different types of failures, but yeah, human error, maybe let's say that's where you have to recover from a backup, do point-in-time recovery, something like that. Now, important to know is that when I've done a lot of like consulting and like architecture design, and when I ask the business that means I'm talking too much about one slide. When I ask, okay, what's your RTO, RPO? It's always like uptime needs to be 100%, so no RTO 0 almost, RPO 0, no data can be lost. But it's important to look into the context of things, because I think when we design something, I think it's fair to say we can achieve quite relatively easily an RPO of 0 in high availability within one region. But if you say I want no data loss when a disaster happens, when a whole data center goes out, things are getting a little bit more complicated. And I hope you're not using the internet for doing all your communication, because the internet is not really necessarily a stable environment, right? So it's important, different RTO, RPO, depending on the different type of failure. And of course, it's very important that the MySQL, or we're talking about MySQL here, or the database is just a part of it, right? The network also has to be stable, or the network also has to be designed to sustain that. I have had customers ask, I want no data loss, automatic failover, but my network often goes out. Or I'm using the internet for doing wide area network, and I want automatic failover between regions. Well, you're going to have a lot of issues with that. So the network also has to kind of support these claims, right? So these are the concepts, and I'll explain a little bit about the different types of architectures that I kind of recommend, or solutions that we have built in MySQL, and then we'll tie them on RTO, RPO, and what they do, what they not do, right? But before I go that, and that's why I kind of ask these questions, is what is it with the how do people deploy, and I'm sorry, I'm going to put in the power here because I think this will help. Yep, it won't go out as fast now. So what is important is that we talk about the past and what people are doing. So one person said, I'm using InnoDB Cluster, but I feel a lot of people are still using MySQL Replication, or maybe Percona XDB Cluster or Galera-based solution, which I think is good. But if we talk about the past, and I see many companies, even bigger companies that just deploy MySQL, is a lot of the work that a DBA has to do is all about setting up and automating the database architecture. You have a primary, and maybe you want 2 secondaries. Well, in the asynchronous world, or in, let's say, more than 5 years ago, like 2016 or before, and you use MySQL, then you would have to set up a primary, then restore a backup of the secondary, configure replication, you have to add a user, you have to kind of set the GTIDs correctly, things like that. So there's a lot of work to be done. And what MySQL did was they gave you technical pieces, like, okay, you have replication, there's a way for you to kind of take a snapshot of the database. There's pieces that we give, but we never fully integrated it. And that's what we have changed since 2016, when our first product, InnoDB Cluster, came out. We started integrating this all to really make it easy, because there's a lot of work DBAs have to do. And for example, my partner is a DBA as well, and a lot of her work that she does, MySQL DBA, I met her at a MySQL conference, by the way. Interestingly. And a lot of the work that they do is automating this setup and making it work and make it their own. But I think a lot of companies, and there are special companies out of there that use MySQL, a lot of companies kind of need to solve the same solution, the same problem. And if we talk about high availability and disaster recovery, it's about RTO, RPO basically. Like, we have some common needs that companies have. There might be different, but they're going to be all in the kind of the same ballpark. I'm not talking about read scale out or any other things here in this slide deck. We're talking about HA and DR specifically here. So in 2016, MySQL released something called MySQL InnoDB Cluster, and that is basically a name. It's just a I wouldn't say it's a marketing name, but it's the name of the product. And that is just a set of, using a set of different technologies, making something integrated. And by that I mean we have MySQL group replication that is being used, and I'll get into that more. MySQL Shell, so you have the MySQL client, but since MySQL 5.7 we also have something called the MySQL Shell. And then we have MySQL Router, which is kind of a load balancer that can load balance traffic, reads, writes, reads, and so on. So all these products together with the MySQL server as well, like, we fully integrate this and we make it very easy to set up an architecture like this, a standardized architecture. One important thing, and there's a lot of features that we added to MySQL 8.0, which went GA 4 years ago, so it's nothing new, is InnoDB clone, which is a way, for example, to, when we add a secondary, in the past you had to provision it, you had to like restore a backup and so on. Now with InnoDB clone, and you can use the feature by itself, standalone, yourself, if you don't want to use the kind of the integrated solutions that I'll be talking about. Is that it would basically allow an empty server here, and you just say clone from this there, and you do MySQL authentication. MySQL connections are opened. It sends us a physical snapshot of the data to the secondary, restarts, and it's up and running, and you can configure replication, and you're up and running. So this is very important, because InnoDB Cluster and the other solutions I'll talk about, they all are run from MySQL Shell. And MySQL Shell runs somewhere remote. And it says, okay, you're a cluster, add a member, add another member, and it does everything for you. For Router, you just say bootstrap. I want to bootstrap connect to this cluster, and that's all you have to do. So really it only takes a minute or two to set up an environment like this. Of course it takes longer if you have 2 terabytes of data to copy. I mean, it's just for an empty setup, it's super easy, and otherwise it's the time it takes to take a snapshot and copy everything over. So what we have here with InnoDB Cluster is an RPO of 0, so no data loss in the case of one server failing, FYI. We have 3 nodes here. You can go up to 9 nodes with group replication. No data loss if one of those fails. If more than one fails at the same time, then we do not guarantee no data loss, right? And then the RTO is seconds, and by seconds it's configurable, but the minimum is 5 seconds. So you can have it fail over after 5 seconds of being a node unreachable or network partitioned and so on. I can give a whole hour, multiple hours of talking around this, but I'll try to be brief because there's more to be coming, right? This is only the beginning. So 2016 we released this. We have a lot of users, a lot of our customers are using InnoDB Cluster, but then we found some other need, like maybe the user. So the first thought was, okay, we have group replication. I'll get more into detail about group replication, and that's easy to set up and that's high availability built in, but not everybody needs this. But what if as a user you don't need automatic failover, maybe your network is not as stable, but you still want the same ease of use? Well, that's why we have InnoDB Replica Set. And what is that? It's basically asynchronous replication, configuring, so the shell configures everything, does the provisioning, configuring of the replication, adding the users, and the same router integration. So basically the same commands you type, but you just say change cluster into replica set, and you have basically an asynchronous replication setup. You can add as much read replicas or secondaries to this as you want. There's no limit. Question? Or just hair? Okay. Okay. No question? Okay. No problem. So that's 2020. That's when we released this. What we released, was it last year, end of last year, or beginning of this year, is InnoDB Cluster Set. And this is just a very frequent request that we have from our users. We had InnoDB Cluster, which really works fine, but we want disaster recovery. Give us disaster recovery. And so a lot of our users know the time before InnoDB Cluster. So what they do is kind of like, okay, let's just set up another InnoDB cluster and manually can configure replication between them. Trust me, that won't work. Why? Because this is an integrated solution. There's a lot of automation happening by Shell, and it won't work as you expect it to be because there's like a metadata schema here. The integration will fail, but a lot of users did set it up despite all these drawbacks that they had to take care of. So that's, we took some time. We took quite a lot of time to make it work. We introduced InnoDB Cluster Set, and basically it's InnoDB cluster, multiple InnoDB clusters. So you can say region in Rome here, and in Brussels, you have a cluster in each. And then asynchronous replication happens from one cluster to the other. And also, like instead of 3 minutes, it takes 5 minutes to set this up. Again, very simple, fully integrated, all automatic. What we then provide with this is, and of course in Replica Set, maybe I forgot to mention this, there is data loss because it's asynchronous. Not semi-sync. We're not doing semi-sync here. If you want semi-sync, you're in InnoDB cluster territory. But asynchronous, so data loss is okay. And failover is manual. This is Replica Set is like a basic version. Why don't we do automatic failover here? Is that the only way to do automatic failover for us is to have a monitoring node make decisions, like Orchestrator or MySQL MHA, or there's been several tools, open source tools available that do this, but we don't want to do that. We do not want to make a monitoring tool that makes decisions and does failover. Why? Because often false positives happen with this monitoring issues. If there's a monitoring host has issues, then it might make the wrong decision and so on. So that's why we have InnoDB Cluster, right? It does have the automatic failover. It's basically using a Paxos-based algorithm. It's Paxos, but it's some variant to it. So it does automatic leader election, does the failover. It guarantees that the data is replicated to the majority before it acknowledges. So there's a lot of features built in that make this not need a monitoring host. So this is a lot better solution. So what we did with InnoDB Cluster Set is that we still have high availability with RPO 0 and RTO of seconds within a region, but then we have a manual failover with some possible data loss. But this is asynchronous replication, so we're talking about if the network bandwidth is not limited, and the servers are not overloaded, we're talking about milliseconds data loss usually. It's not going to be a lot of data loss, if any. So this architecture, very important. It might look easy, but we had to do a lot of features for this. One is we have router, and router is everywhere. And router knows about the whole topology. Router knows about it. Router can connect to both topologies depending on the setting that you use. And I'll show you more what the kind of things that we have built into this. Now the good thing about this is that when you have Rome and Brussels, it's asynchronous, meaning that there's no write performance impact if you write a transaction here. You don't have to have consensus or make sure that another node from the other region has to acknowledge it. There's no issue with that. So you have the same performance with a regular InnoDB cluster, but you have a disaster recovery solution. Yes? Yeah. So why can't we do automatic failover between regions, right? Again, for that we would need a third region, and the one that kind of like witnesses and then makes a decision, right? The kind of the or what is it? The one that can make. Yeah, we could. So there's a couple of ways to implement it. So if you want automatic failover with this, we can't, because we don't have this monitoring host in another region that kind of decides who's the primary. We also, this is group replication stays local. We do not, in group replication, have the concept of an arbitrator at this moment. So something that you're using XRDB cluster, the arbitrator is a possibility. But the problem with the arbitrator is that it needs to receive and takes part of every consensus, every transaction. It receives all the data, and that you need a real data center with low latency as well, because it will be impacted. If you want automatic failover, I'll show you later, you just deploy a single InnoDB cluster across three regions. Then you'll have automatic failover. And it's, yes, because it's asynchronous, it's not, yeah, we need this monitoring host to make that decision. That's why it's not automatic. Did I answer your question? Oh, follow up? Sure. Mm-hmm. It's hard-coded. Is there a reason? There's just concern from engineering that if you do more than 9 nodes, that the communication overhead is too much. So we haven't had users ask for more. And I think if you, like, I don't necessarily see the use case, and maybe we can talk later, of having more than 9 nodes, because usually you want to do this when you have kind of like read scale out or something. You can add asynchronous nodes to a cluster. So, and there's a lot of actually nice features that would help you. And I can show you that later on that make that possible. Yes, Alan. Sure. No problem. Okay, so in InnoDB Cluster, and I think that's my next slide, you can write to all nodes, but there are some limitations. Foreign keys in MySQL are implemented in InnoDB layer, which happens under, like in the storage engine level. So cascading foreign keys are not known to the binary log, which is used to kind of, we don't have the information. The upper levels in MySQL don't have the information available about foreign keys. So cascading foreign keys are a problem, and DDLs are still a problem in multi-primary. You can't drop a column on this node. You can actually, and it will replicate. But if you do a write and use that column, it might break. So there are limitations, and we need to do quite a lot of refactoring in MySQL to actually solve it properly. Yeah. Yes. But note that every member has the full data set and needs to apply every transaction already. So, but I understand, yeah. In cluster set, we even do not allow multi-primary mode. It is a single primary. You cannot enable multi-primary in a cluster set. So we're going to have only one primary, and all the rest is going to be read-only. Even this one is primary, it's going to be read-only. So this is some of the features we implemented. We can, if you do a clean failover here, we guarantee no split brain, because we control that this is constantly read-only. So if we do a failover manually, we make this one read-only, and then we make this one the primary. And we do it in the right order, so we can guarantee like no split brain will happen, which is what some older products kind of did not do very well. They would have the potential for split brain, things like that. Okay, but I'll talk more about InnoDB Cluster now, if that's okay. So, InnoDB Cluster. As I mentioned, it has 4 different components. So we have MySQL servers, we have group replication, we have router or routers, and then we have MySQL Shell. And I'll elaborate on each of them a little bit. And again, I'm staying very high level here because I have 49 slides, and I'm only at slide 14, and I skipped the first 5. So, but anyway, it can go quickly soon. Okay, so the goals of InnoDB Cluster is we have MySQL, and we have so many products in MySQL, but this is about bringing all those things together, all those features together. We have InnoDB Cluster, and that drives the features that we need wherever it is, right? Is it in the router, in the shell, group replication? They drive, okay, this has to work, and they all have to work well together. We integrate it all together, and we test this all together. So we have a QA team that does testing on this environment, right? So it's really good to have, right? Before that, we didn't really have that. We did test replication, we test our technologies, but we never tested the full solution because it wasn't a product, right? So that's important. Easy to use, so it's very simple to use. I'll show you a little bit how the commands look like. It's JavaScript or Python mode, it's quite simple. And then if we talk about group replication, so what group replication provides you, fault tolerance, it's automatic failover. As Alan asked, we can have active anywhere, but with limits, and I mentioned those limits with foreign keys and DDLs. It's automatic membership, so adding and removing members is automatic. Provisioning happens automatic. A physical snapshot or like an asynchronous recovery, that's all part of this. Shell doesn't do anything there. Shell doesn't copy any data. Shell just initiates, add the member, and all the rest happens automatically. Network partitions, failures, all handled automatically within the bounds, of course, of what type of network partition it is. We have conflict detection resolution, so if you write to multiple at the same time and they conflict somehow, we have basically first committer wins system. So the first one to commit will win and the other one will roll back. That's some part of the protocol. So we prevent data loss in this case, of course. So RPO 0, no data loss when a member fails. So a difference between kind of the Galera-based solutions and group replication is in Galera, if you have 3 members, each member has to acknowledge that the transaction was received before the member that executed the transaction will send back to the application, okay, we're good to go, the commit has succeeded. In group replication, the majority is enough. So if this member is kind of slow, the transaction will still continue because there's a majority has received it. So that's a little subtle difference in group replication versus Galera. This also means that if I have one member in another region, you're not going to have that overhead where the consensus will happen local, and in kind of a Galera solution, it has to kind of get an acknowledgement from the other side. So if it's 200 milliseconds, every commit will add 200 milliseconds to it. In group replication, not. Sometimes it does, it doesn't. There's like a mode, single primary mode, by the way. There's some, I'm not going to go into detail. I can talk about it more later, where you can enable that. The downside, of course, is with Galera, you know that the other side has received it, but in group replication, you're not sure because one node there, majority can be reached here in one region. So if this region dies, there's no guarantee the other side has received everything. But yeah, anyway, I drift off sometimes, sorry. So group replication. So it's total order, so writes are ordered. It's basically one bin log, sequential. That's what ends up with write. Yes, question?
What happens if the majority changes? We have, let's say, 3 nodes here, 2 nodes here, and all of a sudden,
Yeah.
2 nodes crash here.
Yeah.
And the majority has to move. Then what happens? The cluster freezes.
The majority will continue, and if the majority does not have the primary, it will get the primary, and the write role will enabled, and the minority will go into isolation, like it will wait. It will wait until the network partition is resolved.
Imagine 5.
Yes.
You have 3 and 2.
3 and 2, yeah.
Okay. So these 2 are delayed.
Yes,
You don't need to apply everything.
correct.
But then in the 3 nodes, 2 fail.
Ah, okay. And the other 2 are isolated as well already?
No, no, the other 2 are fine.
Okay.
Delayed.
Yeah, so let's say, so we have 5, and then the 2 here. 2 of these go away. Then the majority will between those 3, because that's more than 50%. These 2 will isolate themselves, like will go into read-only and not accept any write transaction. If the one isolated was the primary, a new primary will be elected among the majority, one of the majority members. You can configure wait, right? And you can prefer this one if the others are in another location. Okay, that's still the same thing, but when they become the primary, like they were chosen to be the primary, they will you can have a setting that applies the queue before it activates, so it will take a bit longer, and you can also disable that setting. So there's 2 modes, either wait or not wait. Yeah, good. Yeah. Transactions to apply, yes. To queue, to backlog, to apply everything, yes. Correct. That's the group consistency, group replication consistency level before on failover. There's like a setting there. Okay, so we have a half an hour left. So group replication, writes are ordered. It's XCOM, which is a kind of a Paxos implementation. It's more based on Paxos Mencius, which is another variant of Paxos. We have configurable consistency guarantees, similar to kind of what Galera has, implemented differently. So you can have eventual consistency, meaning that if you read from a secondary, you're not guaranteed to see the absolute latest. But if you want, you can do it in several ways. You can kind of configure read or write consistency levels depending on your desire. It is using MySQL replication framework. So the same team that develops MySQL replication also develops group replication. It's the same engineers. Well, it's different teams, but they all know about it. And it's using binary logs, relay logs, GTIDs. Everything that you use in asynchronous replication, group replication loses as well. It's been GA since 5.7, so 2016, end of 2016, I believe it became GA. Yeah, we support it on all our platforms, so whatever platform we support, group replication is supported as well, including Windows. Not that that matters often, but okay, who's running on Windows? Nobody? Okay, yeah. But we do have it. We do have some users. We actually have some big users using Windows, but yeah, it's important. Okay, so no data loss, RPO 0, I've mentioned that. Split brain is prevented because of the way it works with the quorum calculation. I'm not going to go into much detail. Automatic failover, automatic partition handling. You can do kind of read scale out with it, so you can add more members and you can send read traffic to them, all works. There's automatic handling of replication lag using flow control. There's like 20, 30 settings of it to control that. If a secondary is lagging behind, what do we need to do? The primary will start slowing down the throughput. That's what we can configure. How much it delays, all of this, you can configure that with those flow control settings. The consistency levels I briefly mentioned. You can do active-active, but you kind of need to be careful on the workload, right? The cascading foreign keys are a problem. Doing a lot of DDLs will pose a problem, so that's important. Now, good about this solution is optimistic locking, so the write performance is not too bad. I think we have environments that could do like 20,000 transactions per second, so that's actually write transactions per second. In group replication, I think that's kind of the highest we've seen so far in low latency networks, but it doesn't really matter. So we've seen that, so that's good. And the added latency, because of the way it is implemented, we only add one round trip. It's not like a two-phase commit that we need to do. We don't need to like prepare all nodes. Okay, everybody prepared, commit. So that's 2 messages we have to send back and forth to the nodes. This is not done like that. It's basically you send the traffic and the nodes say, I confirm that I've received it. So that's 1 round trip added. And that is enough for group replication to know, okay, the majority has received it, I can continue. We then have a certification that happens to guarantee that there's no conflict. So that happens without communication between nodes. Also, because every member has the full data set, during a transaction, no extra communication happens. It's only at commit of the transaction that any network communication is happening. So you're staying local within a transaction, you'll get InnoDB performance just like you're used to with a single or asynchronous replication. Okay, so briefly a slide on MySQL Router. This is our integrated routing solution. At this moment, there's actually new features that we've released. We released some features last quarter. It's basically you configure your application to connect to the router, and the router will figure out where to go. And at this moment, the router is a layer 4 load balancer, so it does not do transparent read-write splitting. There is a port for reads, and there's a port for writes. So be aware of that. And router will know, reads, I need to use the secondaries. Writes, I need to go to the primary. So that's based on port. It also has like TLS offload, so you can do the TLS SSL connections happen locally if you install router on the application servers, and then the server we have connection reuse even now recently, where the connections remain open and then we just reuse another connection. Authentication never happens by router. Router always proxies the authentication to the server. So if you're familiar with proxy SQL does the authentication. Your user management has to happen in proxy SQL. With router, no, this is as lightweight as it can get. Just very small binary. It will proxy the authentication to a server that does the authentication, sends it back, and that's it. It will never authenticate. But we have this kind of connection reuse. So we do a local SSL, because SSL is a lot of back and forth, so that adds latency. You can do that locally, very fast, and then we reuse another kind of open SSL connection that we already have. And that way you can kind of reduce latency. Router, we have users that have hundreds of routers per group replication cluster or per InnoDB cluster. Why is that? Well, we have like features. So MySQL has the MySQL port 3306, that's the MySQL protocol, but we also have the X protocol on port 33060. And one of the features of the X protocol, apart from doc store and that's our NoSQL API and a regular SQL API, is also notices. And what we have there is that when the topology changes, it sends a notification to all the routers who have a connection open, and they don't have to pull every half a second for the status. They don't have to monitor the status of the group. They'll be notified. So that's why we support like hundreds of routers on a single group. We don't need to do health checking that often because it would overload the database servers. So there's like a lot of little features there. I wish our documentation was a little bit better, so I hope we can work on that, because router has quite a lot of features. But I think we need more how-tos written. So I think I'll give a presentation soon at another conference, I think Cloud World, about all these use cases, all the things that router can do. Also, router works for Replica Set, Cluster, and then Cluster Set. It doesn't matter, it's the same router. So that's also very easy. And then we have Shell. So Shell also was released in 5.7. So you have JavaScript, Python, and SQL. So the default when you log in, it's JavaScript, and you can write your own JavaScript plugins. You can actually write plugins that do all kinds of things. So very, very easy to use. It does this doc store, our document store. It supports just like our connectors do as well. So it does both protocols, the MySQL protocol and the X protocol. And maybe I'll have an example here of how does it look like. I don't have a demo here today because I still have 25 minutes, but that's not enough to do a demo. If I wanted to give all the other 20-something slides. So here's how you connect. You start Shell, and it's in JavaScript mode. You connect to user admin on MySQL 1, and you say, I want a cluster object, and that's dba.createCluster. That's how you create a cluster, a one-node cluster. By default, it will error out because the configuration isn't applied yet. So you're connected remotely on a server, and it will say, the setting, this binary log setting is not good, or this or that, or server ID isn't set yet. Well, DBA configure instance on admin at MySQL 2 or 1, so let's say we want to add member 2, it will configure it. It will say, okay, all these settings we need to change. Do you want me to apply that? Yes. Do you want me to restart the database if it's not dynamic? Yes. So MySQL 8, you can change set persist only. There's a restart as a command, so you can restart the database. So we can do everything we can do remotely from a machine. So if you have containers, which is kind of common nowadays, you can just connect to the MySQL. You don't have to get a shell somewhere on a container to execute commands. Everything happens remotely over that MySQL connections. And you can configure it, set any variable, restart, and so on. It will do that all for you. Let's say you want to add the instance. So we have the cluster object that we created here, and it's like a one node cluster, and we do cluster.add instance MySQL 2. Ta-da! It will say, okay, I have no data, you want me to provision it? I can do either binary logs or I need to clone it. What do you want? If it knows that there's not enough binary logs available, it will say you need to clone it. So you can do clone, it does all the cloning for you, and it adds the member to the cluster. If you then want to add MySQL 3, it's the same command, add instance MySQL 3. But if you then want to configure router, this is the only thing you need to do. MySQL Router, so on the wherever you want to install router, as user MySQL Router, that's the shell, that's the kind of Linux or Unix user you want to run as. Bootstrap. That's all you need to do. Well, you say the host name, right? MySQL 1, for example. And then you start it, and that's all it needs to do. When it bootstraps, it connects. There's a metadata schema. It knows based on the metadata schema we should have MySQL 1, MySQL 2. And router generates a config and then updates kind of a state file as it runs. It monitors that metadata to see if there's any new members whatsoever, what's the status of these members. Then you can get the cluster status. So it's one of the commands, there's many. And then it gives you a JSON output with the status. So we have the primary as MySQL 1. It's in read-write MySQL 1. And then we have two read-only members here, MySQL 2 and MySQL 3. You can do like extended status, you can remove instances, there's all kind of operations that you can do. But that's basically how you deploy a cluster. And if you want to deploy a cluster set, which I'll talk about later, it's just basically cluster.create cluster set, another member. And there you have it, you have another cluster. So it's almost the same command to run. So Replica Set, one slide only on that. It's less frequently used, but still we have users for it. Is same integration, but it's asynchronous. It still does the cloning and the user handling and the configuring of replication, and it's manual failover, but also Shell provides all the functionalities to do a manual failover. Even in cluster, you can say set primary, you can change the primary. Here you can also say set primary. Oh, I want this to be the primary because I need to do some maintenance here. Sure, you can do that. Shell will automate all this for you. If you want to make it automatic, it's up to your responsibility. You can just write a wrapper that does health checking and then does set primary or force primary. So we have set primary, which is a switch over, like a clean changing of primary, and then we have force primary, which is a failover that we do, which of course can create some split brain, but it will tell you all that, and then you have the opportunity to kind of do a stone it or whatever you want to integrate on how you want to use this. Okay, any questions so far? Now we go to cluster set. I'm just talking all the time and nobody else is, so. I see people nodding, so that's good. A few people are falling asleep, but that's also fine, you know. No questions? Now, this is one of kind of the latest development, right? Is cluster set. So we talked about InnoDB Cluster. We have cluster set now. So the same exact ease of use as with the commands, how to set it up and what so on. You can have one cluster, but you can also have multiple clusters. So let's say the primary cluster is in Rome. We have one in Brussels. Well, you can have one in Lisbon. You can have as many as you want. There's no limit, actually. We didn't define a limit. Like there's 9 nodes per InnoDB cluster. There's no limit on the amount of cluster set clusters, but I think there's be a practical limit or some kind, right? You also are not required to have every cluster to have 3 nodes. You can add a third data center with a single node if you want. You won't have high availability in Lisbon, but you can if you want. Nobody's going to prevent it. It just works. Okay, simple. Here, let's say we have this environment. This is, okay, a little bit of route. Oh, questions. Sure, ask the question first. I'll explain it. I have a couple slides, but I'll explain it here already because I kind of have to put some context on that. So let's say we have two data centers, so Rome and Brussels. The primary is in Rome. We have 4 routers, 2 in each. We have a target mode. It's a bit hard to see. I need to change the font here. You have different target modes. And important to know, and it's weird nobody has asked yet because I get this question a lot, can I do bidirectional between clusters and can I do it active-active between clusters? The answer is no. Why? It's asynchronous. We cannot guarantee that there's not going to be any conflicts, so we are not going to make a product that is going to make you lose data or have a split brain. So either we will have a fully supported solution that will guarantee that there's no split brain, or just go and deploy your own group replication and whatever you want to do, but not in our solution, right? This is, you're laughing, but a lot of people are doing this, right? So many people, and I have to talk a lot of people out of this. Yes, and you too, right? At your work. Okay, router knows. So the default way router works is target primary, which means it will send writes, which is red, and then reads in green. It will send it to the primary cluster. But you can also change the target mode. This one is in target mode Brussels. This one is in target mode Rome, which means that, well, I made it a reporting application because it only does reads. But if you send writes to this one, writes will go to this one because the primary is in the primary cluster. So Rome is the primary cluster. It has the read-write node here. In target mode Rome, if we send a write here, it will go here and it will send it here. Now, it's a little bit of a decision we had to make. If this one is in target Brussels, if a write happens here, the write will not continue because there's no writer here. This is the current situation. You cannot say target Brussels but send the writes here. We can add that to the feature of the code, but it would delay us the release of this product. So I was like, we need to release this as is and not delay it. And one of the things important for this is this router is so lightweight. Just run a router with a read-only and run another router with a read-write mode, and then you can have it as target primary, and then send your write traffic to that one, and that one will follow the primary, and then this one in target Brussels will send the reads always local. So it's because router is kind of lightweight. Now this router will know within seconds that a machine has shifted, right? Like let's say this became the primary, router will detect it within seconds. What else is important here? Oh, you can change target modes and the features that we're doing now to router. Router, as I mentioned, is lightweight. We do not want to do authentication there. We do not want to we want to keep it lightweight. And the way you configure router for these modes and other settings that we're having is you do it through Shell. You just say, this router needs to change its target mode right now. What happens is Shell updates the metadata here, router will know, oh, my target mode has changed, and it will change the way it behaves. So what we avoid trying to do is, we don't want you to have to change a config here. We also have a REST API to check the health status of every router, but knowing that routers can be deployed everywhere, we don't want Shell to have to connect and send an API request. No, we can all do decentralized because there's a database. Hey, look, we can use the database. It's highly available. The data is there. So we use this. We heavily rely on this to just update its config, and router just learns about the changes. It's a very neat, small, simple design, but it works. So it makes it really, really possible and flexible. Oh, 2 questions. Yep. Yes, this is fully using GTIDs. Oh, good question. So The question is, what about GTIDs? So GTIDs, Global Transaction IDs, I think was introduced in MySQL 5.6, or is it 5.7? I don't know. It used to be that if you configure replication, you had to configure binlog file position. Like you change master, it was then, now it's change replication source, is a new syntax. It says, okay, this is the file, this is the position. The problem is, if you want this machine to replicate from this one, the binary log file and position is different than this one. And with GTIDs, global transaction IDs, there's a way to say, just replicate from this one. You know what you've applied already. It's like, just GTID set I have, I don't have this, give me whatever I don't have yet. So this heavily relies on it. Group replication uses one GTID per cluster. So we have two GTIDs here. To be more precise, there are two GTIDs per cluster. There's a management one that we had to implement. Yeah, it's an implementation detail. We had to add some features to make this work. We had to add another kind of a management GTID. So you'll regularly see 4 GTIDs if you check the GTID set. Yes. Yeah. It's the view change UUID. Group replication view change UUID. The reason why is that if a primary switches here, like something happens or you add a member, a UUID is sent with the change, the new topology. But in a split brain situation, you create GTID inconsistencies between them. So that's why we put it on a different UUID so that we can reassemble it and we know it's a management. We can ignore the management GTID events. Yeah, yeah. Okay. Sure. Yeah. Yeah, we don't, because then we need to have users and passwords here in the router, and we don't want to do that. Yeah, and it's so SSL happens local. We can have that, but then the authentication is just the authentication string, and yeah.
So why did you not want to do it there? Like I realize you wanted to do locally, but like
security. Yeah. You have to start replicating users. Yeah. Yeah. Well, they could sync it, right? The routers could fetch. Yeah. Yeah, and we also have this audit logging that we might want to do as users. We have like in our enterprise version an audit log, so we want to know who authenticated. So we want to keep control here. And the overhead that we've seen, we don't have users complain about that, about that specifically. We're also adding kind of like connection reuse to the mix. It's actually the connections are reused, right? So the overhead becomes less because we don't have to open a new connection. So less overhead.
is there a small limit on the connection pool?
You can configure it. You can configure the pool how you want it. Yes. Yeah. Whatever you want. Yeah. There's no limit. Yes, you had a. Mm-hmm. Yes, you can connect the replica through a router. Yes, that works. Yeah, that works. But we added features that we don't need to do that. And I can show that. I can show that in the next couple of slides, yes. Whew, 3, 4 questions. Yes, go ahead. Yes.
How long does the connection stay alive, and how do you know if that connection is still viable?
Yeah, so there's a timeout configuration for that one. There's a limit on how many you want. And it's also not in total how many. It's actually per user and connection capabilities. Because remember the authentication, we don't want different users to use the same kind of connections. So there's a little bit of difficulty around that. And then what was the last? Yeah.
You've answered it, which is that
Okay.
you're using parameters time to live, and you're using number of total users
Yes.
of the connection, and then it renews once it hits.
Correct. Yeah. And it's just, I think the configuration is if you have that many idle, start closing them. So keep that many idle as you want.
So it's pretty similar to other types of
Yes.
connections.
Yes, but router by itself cannot open connections because it doesn't know how to authenticate. So it needs a user originally to open an original one, yeah. And there's a bit of a trick. We need to keep state of the connection tracking, session tracking. Like there's a lot of state we have to manage and make sure that they are compatible for the different users. So things get quite complex. Yes, question. The router instance, or new connections have to be opened. So the application then authenticates again, and router is basically a man in the middle. That's what it does. It kind of, yeah, it knows some things, but it doesn't know the clear text password, but it can use whatever hashes were there to kind of forward it at least. But it doesn't have access to the actual password. Bootstrap once. Yeah, question.
This implementation here, I guess it's a high availability.
Yeah.
What about a disaster recovery architecture where you have one of these sites, and one instance is on-prem, and the other somewhere on the cloud?
Mm-hmm.
Is that a use case for this?
I'll show you. That's what the scenarios. I'll show you the scenario. After these slides, I have some scenarios. What if a region dies? What to do? I'll show you.
In this diagram, we have this from reversal. One of the indication is when the target is right here, the red line, right?
Yeah.
So when I bootstrap it, how do I bootstrap?
You bootstrap to any of them. It doesn't matter because router figures it out what to do. Router will know, oh, bootstrap to this one. It will see the metadata. It will know that this one is the primary, and it will register through here, and it will replicate to everywhere, and that's it. Yeah. Yeah, you don't have to know the primary. That's easier for automation. When you automate this, just give it one of them, and it's enough. Sure.
Related question on the router. Is there a number of connections, the total number of connections limit to it? You mentioned that the router
No.
can be lightweight,
No.
but it can handle as many as the underlying OS can handle?
Yes, I think we switched to, what is it, event-based. We don't do threads for each connection anymore, so that's better. The scalability kind of depends on router, but it does seem like from what our users say, they haven't raised any issues on that yet. Yeah, yeah. Anyway, I have a couple more minutes and 19 slides, so yes, correct. You can actually switch if you want. Okay, let's show some use cases and scenarios, right? Let's get down to it. I have 7 minutes. Okay, good. Let's say we want to switch the primary cluster. So this is manual. So changing a cluster, this is a clean operations that I'm going to show you. You have two regions. You just want this one to become primary because the workload shifts there, or you want to do some maintenance, whatever, right? It is one command, set primary cluster, and you just say, change the cluster to here. So in purple is everything we do, right? Replication will be reconfigured. This one will become the primary, and this one will become the secondary. So router will also know, oh, I have to connect here now, and it will start connecting here. Target primary, writes come here, writes suddenly move there. These writes will also move to that one. So this one command, and it will do automation, all the work necessary for you to do this. A second, or yeah, it's very fast. There what? Well, yeah, what we need to do is we need to put the primary, all primary read-only. All connections that are ongoing need to commit or roll back. So it kind of depends on your workload, yes. Yeah. Okay. Then router, I think I mentioned most things already, so I'm going to skip some things. Then, because I've mentioned it's the target modes, I've mentioned these things. So scenarios, as the person mentioned. What if something happens? Scenario number one, the primary dies. Not the whole cluster, just the primary and the read-write member. The primary of the primary cluster. The primary member of the primary cluster dies. What happens is InnoDB Cluster or group replication will just elect a new primary. This one will become the primary, and automatically the async replication will also move to the new primary. So that's fully automatic. So we had to add some features to asynchronous replication to make this all happen. You can actually do this all yourself. If you just use regular asynchronous replication in MySQL 8, you have the concept of not change replication source to master host. You can set you give a list of it even. And even the replication knows about the group. So it kind of knows about the whole cluster. Let's say this one dies. The replica cluster primary, which is read-only, but is one receiving the transactions. If this one dies, replication will be restarted and will continue here. Fully automatic, so you don't have to do anything. So these are kind of the common cases, right? If you do the clean switch, it also does it automatically. Now, that's what you mentioned, the use case. Let's say it's partitioned. Not it didn't go on fire, it didn't lose connectivity. We have two clusters, right? This is asynchronous. So our application is stuck. Nobody can access this application. So what do you want to do first is fencing. You want to fence it. You can actually fence it. We have features that we added to fence it. You can say fence writes. So we know, because we don't want to, writes can still happen to this one. It's the old primary. So we need to reduce split brain as much as we can. So you can do fence writes, and it will put the whole cluster in read-only. Or shut it all down. You can kind of choose what you want. Assuming you can get to it, yes. Correct. If you can't get to it, maybe power went out. That's a good thing, right? But if you cannot get to it, there should be ways to get to that isolated one, right?
Just maybe not immediately.
Yes, correct. But yeah, but maybe you can access through some console, some other way, or there's another internet line to get in. Yes, correct. Yeah. You put the whole cluster to read only, yes. Correct. Yeah. Not cluster set, correct. Yeah. You do it on a cluster. Yeah. Yeah. Well, this one is still a replica. At this point, it's still read only. So you fence first, if you can fence it. If you don't have to fence it, but it's up to you. We do recommend it, of course. So suddenly everything now is read only. What you now want to do is you want to make it read-write. So you do force, so not set primary cluster, you force primary cluster it. And you say, you make this one read-write. So router will notice, oh, I have a new primary here, and it will start sending write traffic here. Now, because we fenced, if the application still, so cron job might be running and might be doing some updates on the database. That, without fencing, that will still happen here. And we have a split brain situation. So with the fencing, we reduce that possibility. Now, what happens if the network partition goes away and it recovers? These routers will notice that there's a new primary. So in the metadata, it knows that this one should be the primary, not this one anymore. And they will automatically send all the traffic there.
What happens if on the first cluster there was a primary that weren't able to fence it? Did the force
Yes?
set master?
Then is this. Yes, it will know it as soon as it can connect to that cluster again. Yes. So here it's read-write, and that one will be read-write. But if we switch, yeah, it knows. Correct. And I have 1 minute left. A lot of questions. Now to summarize, so you can see the slides online. To decide when to use what, right? If it's HA. We have InnoDB Cluster, no data loss. RTO, the time to recover is seconds. With Replica Set, there is possibility for data loss. RPO is minutes. With multi-region disaster recovery, we've showed you this, right? InnoDB Cluster Set, which means RPO is 0, RTO is seconds within the region. Write performance is great because it's asynchronous. The RTO is higher on disaster recovery because you have to manually failover. Now, one thing that I haven't talked about is that you could also deploy a single cluster across 3 regions and you'll have full automatic failover. You'll have no data loss when a region fails. You can add 2 nodes on each, fine, because then you have some kind of local high availability. So this is also something possible, but you need very good network for that, and your write performance will be affected by the latency of this. So this is another one. This is, well, synchronous, none of them are considered synchronous, right? It's yeah, or virtually synchronous, whatever concept you want to call it. But you can get synchronous if you want, yes. Anyway, that's it. There's some links. Everything is available, open source, use it. So, and that's kind of the direction and a lot of effort that we put in. So if you have any more questions, that I have to stop because the next talk is. The slides I will put online. Slide share or on Oracle, Tina will add it. And I'll upload them now today. Yeah. Okay, thank you.